Hello and welcome to Easy Math with Ruxar. So today we are going to do the chapter 2, which is the square root lesson. So here we get started with square root. Okay, so now what exactly is a square root? So we might have heard about square numbers, right? So what are square numbers? When we have 1 multiplied by 1, that is the answer would be 1. So 1 times 1 equals 1, that's a square number. 2 times 2 equals 4. It's another square number. 3 times 3 equals 9. So we have a few square numbers. So 4 times 4, 16. 5 times 5, 25. And 6 times 6, 36. So it goes on. But now the question comes in, let's say if we have like a huge number. Okay, let's say we have the number 625 or maybe even larger than that, 1025. How would we find the square root? Because the simple numbers, it's quite easy to get the square root. For example, if I ask you, okay, what is the square root of 36? You might give me the answer, yeah, 6 times 6 is 36, hence the square root is going to be 6. That's pretty simple, right? But it may not be the same case when it comes to bigger numbers. So today we're going to see two methods of finding the square root. So the first method, or the first thing that we are going to apply is the first approximation or the approximation method. Now this specifically comes to when the numbers are not square numbers. Now we knew the square numbers was 1, 4, 9, 25, 36, that way. But let's say, for example, somebody asks you to find the square root of root 17. Okay, so find the square root of 17. Now 17 is not a square number. So how would you find the square root? What is the value? So approximation is basically like a guess or like the closest number. Not the exact one, but an approximate value. So how do we do this exactly? So let's look at the example 1. They're asking us to find the square root of 17. Now when you look at 17, the first thing that you need to do is find the closest square numbers. Now like I told you, square numbers are pretty easy to find. You multiply a number by the same number. So 8 times 8, 9 times 9, that way you get the square numbers. So now to 17, the closest square numbers are 16 and 25. So basically 17 is larger than 16 but smaller than 25. Now if I take the square root of 16, I know that the answer is 4 because 4 times 4 gives me 16. So square root of 16 is 4 and square root of 25 is 5. So now my answer should be in between 4 and 5. So now comes the question, okay, so 4 and 5, what in between? We have 4.1 to 4.9. So what exactly would the answer be? So for that we have another technique that we are going to use. Now if you look at the numbers 17, it's really close to 16. Basically the difference is only 1. But if you look from 17 to 25, it's quite a big gap there. Yeah, you have almost about 8 digits there. So when you look at that, you know that the answer should be more closer to 4. It should be really close to 4 and not towards 5. So when we look at this, we get an understanding that it's definitely the answer is less than 4.5. Because when we look at the halfway between 4 and 5, it's 4.5. So it's more closer towards 16, which means it's more closer towards 4. So we know we eliminate the values more than 4.5 and we come towards 4.1, 2, 3 and 4. So now we need to figure out, okay, now we have 4 options. So we had 9 options initially, we eliminated and we have 4 remaining now. So out of these 4, what is the correct answer is the question that comes in now. So how do we check that part? So to do that, what you need to do is you need to multiply because we know it's really close to 4.4. I mean it's close to 4. So it should be something around 4.1 or 4.2. It's even a less possibility for 4.4 or 4.3. But anyway, we can always check it out. So we're going to multiply 4.1 by 4.1 equals 16.81. So before we move, deeper into that part, I'm going to show you how we multiply decimals because I do understand like some of us still struggle with multiplying decimals, even though it's something we've been learning. It's all alright. Let's go. Let's do it. So when you're multiplying decimals, it's pretty simple, just the way we do the normal multiplications. let's forget that we have decimals right now. Let's just say there are no decimals and we need to multiply. So we just multiply 1 by 1 and 1 by 4. Those are the two steps that we take in. So I'm going to write 1 times 1 is 1 here, and 1 times 4 is 4 here. So 1 under the ones, 4 under the tens. We are done. We're good with that. And then let's not forget, whenever we do the multiplication, we need to put in the placeholder. So I'm going to put in the placeholder there as 0. Now the problem that comes in is multiplying 4 by 1 and 4 by 4. So 4 times 1 is 4 itself. So let me write that just a little bit here. 4 times 1 is 4 and 4 times 4 is 16. So I put the 16 there, and now we're going to add them together. So when we do the additions, what happens here is we have 4.1 times 4.1. So we're going to add 1 plus 0, which is 1 itself, 4 plus 4, which is 8, and 1 and 6, 6 comes as it is, 1 comes as it is. So the final answer there would be 1, 6, 8, 1. So that's the answer when you multiply without the decimals. But now we need to add in the decimals in here, right? So you're going to look at the place values here. Like, from behind, there's one number, one digit, and then the decimal point, one digit, and then the decimal point. So 2 places basically. So you come back here and move 2 places and put the decimal point here. So it's going to be 16.81. That's how you do the multiplication there. All right. So likewise, you can multiply 4.2 times 4.2, which gives you 17.64. Okay, now we are still not towards, we've not got the exact answer, because 16.81 and 17.64 is still not 17. But just because I say the 17 here does not mean that my answer is going to be 4.2. So now how do we figure out? So basically what you're going to do now is you're going to see which number, 16.81 or 17.64, is closer to 17. So which is the closest? So for that, we need to subtract the smaller number from the bigger one. So 17, from 17 I'm going to subtract 16.81. So when subtracting decimals, remember 17 is a whole number, but 16.81 has a decimal point. So I'm going to add the decimal and put 2 zeros here and make it 17.00 subtract 16.81. So 16.81. Now this is my subtraction that I need to work out with. So how will I work that out? Now remember another thing, we can't subtract when there's a 0 here. We need to borrow there. So when you're borrowing, we can't borrow from 0. So tenths, hundredths, nothing there, so we nothing to borrow. So we move to the ones itself. So there's 7, we borrow it, we move it here, 10, we borrow again, this becomes a 10 and this becomes a 9. So 10 minus 1 will give me 8, 9 minus 8 would give me 1. So now I have 0.19, and on the other hand this is 16, and 6 subtract 6 is 0 itself, 1 subtract 1 is 0, so I have nothing there but 0, 0. So basically the answer would be 0.19, right? So this is the difference between 17 and 16.81. And if you look at 17 and 17.64, so I've got to subtract 17 from 17.64. So if you're subtracting this, it's pretty much easy and obvious there itself that when you're doing the subtractions, you have nothing but 0.64 itself. So now if you look at this 0.64 and 0.19, which is more closer, is another question that comes in. So 0.19 is much more closer to 17 than 0.64. So because of that, we would say that the answer is 4.1 and not 4.2. So that's how the first approximation works. Remember, when it comes to first approximation, it's your answer to one decimal place. Right? There are second approximation and third approximation and things like that, but for your syllabus we do not go into depth. We stop with the first approximation itself. So that was because I hope that part was clear to you, and let's move to another question before we move to the division method itself. Right? So here I'm just going to take you through the steps simply to give you a better understanding. So when it comes to the example 2, you have 245. So when you talk about 245, once again, you have to figure out what's the closest square number. Now, let's say you're not sure. Okay, you don't know the square numbers. 245 is a big number. So then what happens is you just randomly multiply a few numbers. You multiply 12 times 12 and check, okay, so this is 12 times 12 is 144, 144. So no, I have to think of a bigger number. That way, keep multiplying, and I'm sure you'll find the closest number to 245. So when you get the closest number, they're going to be 225 and 256, which is 15. The square root is 15 and 16. So we get an understanding that the answer to this should be between 15 and 16. So next step, so first step is find the closest square numbers to the given number, two closest, right? And then what you do, you figure out the square root of the two numbers that you found, and then you figure out which is more closer. So is 225 closer to 245 or 256 closer to 245? So for that, what am I going to do? I'm going to find the difference between these two numbers. 25 and 45, 35, 45, basically 20. And then when you move to the next part, 45 and 56, what the difference there would be, like, 45 and then 55 is 10, plus 1 is 11. So the difference between these two is 11. So now I know that my answer is closer to 256 and not 225. So basically, my answer is more closer towards 16 and not 15. So the options that I had was from 15.1 to 15.9. So now I know, since it's much more closer to 16, it has to be more than 15.5 or above, right? So that's how we figure out, like the elimination that we did. We eliminated the numbers that were closer to 15 and we took the numbers above 15.5. So when you look at 15.5 and again you multiply 15 point, I mean it's easier to start from 15.9. I mean, you don't have to do all of this, but you can select a few and multiply and then check, like, okay, this is closer or that is closer. That's up to you to figure out which one. But since this is an example, they've worked out all of them. So 15.9 multiplied by 15.9 is giving us 252.81. So we needed 245. So definitely we know that that's not something close. So maybe we can look at a number less than that. So 15.8 times 15.8, 249.64. Maybe it can come in, but let's move to another number in sec. So 15.7 and 15.7, 246.49. Oh, that's like really close to the number that we want. So we highlight this, or we keep this as maybe a possibility. So next we move to 15.6. We move one more down just to check it on. 15.6 and 15.6 is 243.36. So when we look at this part, 243.36, 46.49. So by just looking at this number, we know that it's somewhere close to 1.49 here. So okay, let me use the text tool. So this is 1.49. So I'm just going to use my little fingers to figure that out. 243.36. So let's say, for example, how close is this part? You have 1.49 there, but 243.36. So 36 to get to 100, or let's say to get to 244. How much more do we need? That's a question that comes in, right? So 36 to 40 is 4. 40 to 100 is 6. So that's 64. So 0.64 is what will give us 244. But what do we need? 245. So it's 1.64. So do you see, it's like a very teeny gap that they have. 1.64 here and 1.49 for 15.7, right? So when we look at that part, we know that, okay, 1.49 is a smaller gap compared to 1.64. So that is why we've gone with the answer 15.7 and not 15.6. So that's more about first approximation. Though this is not really tested in your examination, there can be one question in the two mark question, 1-2 mark question there, that they tell you to use either the division method or if the first approximation, or they can give you a choice, either way you can figure out the answer. Anything is fine. So just to give you an understanding, this is how first approximation is done. And we have a few questions under that exercise 2.1 where they're asking you to find the first approximation. So maybe you can work that out. And if there are any questions, you can definitely email them to me and I'll help you out with it. So moving to the second method itself, that's the division method. So the division method is really different from the first approximation method, because approximation was like a guess that we went towards, but the division method is also a first decimal, we can go up to 1, 2, 3 decimal places there based on the question that they've given. So the first thing that we need to do is, like, step 1 says separate the number. Now we're going to find the square root of 1764. So we're going to separate it and put them in pairs. Okay, but remember, when you're putting them in pairs, we start from the units position, or the ones. So 4 and 6 comes together as 64 and 17 together. So now we have our pairs here. So what do we do next is our question. Now 17, 6, 4. Find the closest. So let me just quickly draw that division method, the division bar here. And let's put the question as well. So 17, keep some space and put the 64. It's just like dividing, but make sure that you have a space, because we work in pairs for the division method. So 17 and 6, 4. Now from where did they get this 4 is another question that comes in. Okay, so now we find the closest square number to 17. So to 17, the closest square number, the one less than 17. Let's remember, it's not more than 17, it has to be less than 17. So the square number less than 17 is 16. So when we talk about 16, the square root of 16 is 4. 4 times 4 gives me 16. So what I'm going to do here is I'm going to write 1 4 here and 1 4 above, and write the 16 here to show that I am doing a subtraction there. So 17 minus 16 would give me the answer 1, right? So I've done the subtraction like how you would do the normal division. You get the multiplication, you multiply them and then get the value, subtract it, and write the remainder. So that's exactly what we've done. Now when you're normally in division, when you're bringing down the next number, you bring only one digit. But here we're going to work with the pair. So we're going to bring 64 down, and not only 6 or 4. The whole thing 64 comes down, right? So when the 64 comes down, now we have 164. So we need to figure out how to get 164. So the next step, what we do is we double the number that we have here. We double the 4. So when you double the 4, you get 8. So I'm going to write that 8 down here. Now the next thing that you've got to do is you have 8 and you put down a blank, multiply that by another blank. Now what exactly does this blank mean? So let's say if I'm filling this in with 1, like 81, then I have to multiply this by 1 as well. It's going to be 81 times 1. Or let's say if I'm taking 82, then I have to multiply that by 2. It's 82 times 2. Now 81 multiplied by 81 is going to give me 81 itself. So that's nothing closer to 164. But if you look at 2 times, like 82 times 2, 2 times 2 is 4 and 2 times 8 is 16. So we see that we get the value 164 exactly there. So that is why we figure out that, okay, the 2 is the right option there, because 82 times 2 gives exactly 164, and that's what we want. So what I'm going to do here is now put the 2 here and put the 2 here. So 2 and 2, the one that I filled the blanks with. So 2 and 2. So then I can subtract 164 because I got exactly 164 when I did the multiplication. And now the remainder would be 0, 0, 0. So there's basically nothing remaining. So the answer to this, it would be 1764 is 42. So I hope that part was clear to you. That's exactly what they've done here to show the steps and how they figured that out. The 2 is also there. So you can apply this, not this is a square number. 1764 is a square number because we are getting a perfect square of 42 with nothing remaining, no decimals, nothing. So if you have a bigger number and you really don't know, you're clueless how to do the multiplication, then this is the best method that you can apply to figure out what exactly the square root would be. So here we have for 1764 we have 42. Now moving to the decimal part of this itself. Let's say the question has a decimal and they want you to find the square root with the decimal point. Now 3.61, if you remember, we were told to pair them. So pairing happens this way. If you are talking about the whole numbers, the ones, the tens, the hundreds, it happens this way. And when we talk about the decimals, it happens towards the right. So what I mean by that part is, if you look at this one, this is 3. We have nothing in front, so we can maybe put a 0 if you want to, or we can just skip it off. So 3.61, this is the pairing that happens. 12 is already a whole, it's a pair, so there's no problem. But remember, when you talk about 3, 2, 1, the pairing does not happen from behind, because after the decimal, it has to happen towards the right. So because of that, we say 32 is one pair, right? And 1, since it has nothing after that, we add the 0 and make it 32, 1, 0. Likewise, 143.456, this way you divide 43 as one pair and 1 separate, so 1 and 43. But after the decimal point, it's 45 and 60. So that's how the separation or the pairing happens when it comes to decimals. That's what they've shown in this particular part here. So I hope the division method is clear as well. But since we have examples here related to 3 decimal places where they've given us answers where they have 3 decimal places, I'll just quickly work out one more example before we move on to the exercises itself. So this question is find the value of 2737 accurate to 2 decimal places. Now the question says to give the answer in 2 decimal places, which basically means we have to find the answer to 3 decimal places first and then do the rounding. Right? You can't stop at 2 decimal places just because the question says so. When they say accurate to 2 decimal places, you find for 3 and then do the rounding. Now let's look at this one, 2737. The pairing is done first, so 2, 7 and 3, 7. Now for 27, the closest square number is 25, which is 5 times 5, so 25. That's what they've done. And then when you subtract, you get the remainder 2. Let's not forget the pair has to be brought down. So they've brought down 37. Now 2 and 37. So what was our next step? We double the value that we wrote here. So 5 times 5 times 2, the doubling value, double of 5 would give me 10. So now I need 237. So I need to figure out. So I have 1, 0 and I need to fill this blank in. So maybe I can fill it with 1. So I have to multiply this by 1 as well. But when I multiply this by 1, I get 101 itself. That's not close to 237. So I'm going to change it to 2 and check my answer. So 102, multiplied by 2. So I get the answer 204. That's somewhat close to 237, because I can change this to 3 and check, but I'm pretty sure the answer that I get would be 3 times 3 is 9 and 309, which is much more than 237. So I can't take 3. I come to the conclusion that I can take 2 here. So when I move with 2, what happens there, you have to put that 102, that was 204 when you multiplied them. So you write 204, do the subtraction, and 7 subtract 4 is 3, 3 subtract 0 is 3 itself. So you have a remainder of 33, but you've got to put the 2 here and another 2 here. So now after this, you don't have any whole numbers remaining, so it's you have something really blank there. But we need to continue because we have to give the answer to the closest 2 decimal places. They are accurate 2 decimal places. So you put the decimal point, and remember, when you are adding zeros to this, when you're putting in the zeros, they also come in pairs. So 2 zeros at one point. Alright, so 33 and 2 zeros, 3,300. We need to work this out. But what's our next step? Now this time when you're doubling, you're not just going to double 5 or 2, you're going to double 52. So when you double 52, you get the answer 104, and you need to find what's the closest number that will give you the answer 3,300. So by just looking at it, okay, 1,000, 2,000, 3,000, maybe, 3 would give me the right answer, somewhere close to that. So I can check that out by multiplying 1,043, multiply that by 3 itself. So when you do the multiplication, 3 times 3 is 9, 3 times 4 is 12, 1 remainder, 1 comes down, and 3 times 1 is 3. So 3129. So I'm going to quickly write that down, but 3129. Still less than 3300. So then when you do this, you do the subtraction. It's like the same process repeatedly happening, right? First you double the value, get the closest number, and then you subtract it, get the remainder, add 2 zeros, and continue with the same process again, right? So when you do the subtraction, 3300 minus 3129, you get the answer 171 over here. So we are done. Now we put the 3's here, 3 and 3, so we have 52.3 now. So next, when you're doubling, you're going to double not just 52, not just 5, but 523. So when you double 523, that's going to give you 1046. So 1046, when you're doing now you need to figure out, you add the 2 zeros here, you have 100, 17,100 there. So 17,100, you need to figure out which number would be closer. So now when you add, you have 1046 and you put 1 here, you have 10,461. That's pretty much the only thing. Even if I put this as 2, 10,462 times 2 would be more than that. It will give me somewhere around 20,000. So I know that I can't go beyond that, so I can just stop with the 1 itself. So I put the 1 here, put the 1 here, and do the subtraction. And when I do the subtraction, I get 6639, 66 and then 39 here. So I add the 2 zeros again. This is like a continuous process that is happening. Remember, like I told you, I can't stop here. I have to find the third decimal place before giving my final answer. So 6639 and 2 more zeros come in there. So now I need to double 5,231. That's 10,462, and I need to figure out what the answer would be. So you can keep putting in values. You can try with 5, and then if you feel like no, this is not the one, you can go for the 6 and then figure that out. So the final answer would be 6 there. So when you do the subtraction, you still have a remainder. But don't worry, we do not have to go further because our purpose is done there. We have got 3 decimal places. Now the question that comes in next is we have the answer 52.316. So what's the final answer? How do we figure that out? So we need the answer. We need it in 2 decimal places and not 3. So when you're rounding, what you need to do is look at the third decimal place. Third decimal place is 6. 5 or above, we round up. So it's 5 or above. So this increases by 1. So 1 plus 1 will make it 2. So your final answer would be 52.32. So that's going to be the whole, accurate to 2 decimal places. I know it might be a pretty overwhelming because the process seems really long, and it's a lot of numbers that you're dealing with, but I'm sure with practice it's going to be really easy once you understand the steps that you have to do. What do you have to follow? So remember, it's first thing that you have to do is pair the numbers. After you pair them, find the closest square number to the first one. Remember, it has to be less than the number that is given. So if it is 27, 25 is what we can take and not 36. So 25, do the subtraction, get the remainder, take the other number pair down, double the answer that you got at the top. Double this 5, so you got the 10, and then fill this blank with the correct one that you think, which gives you the answer closer to 237. And then do the subtraction, find the remainder, and continue with the same process again and again, right? So that's how you get the answer to this using the using the division method. So that's it there. Let's look at the exercises, and then we are almost done with the chapter itself, because those are the 2 important methods that are being shown here. So in this question, you have find the square root of each of the following numbers, and here find the value accurate to 1 decimal place. So basically you find the answer to 2 decimal places and then round. Like I told you in the exam, this may come, or maybe it gets connected with another question, because finding the square root is there. When you use the Pythagoras theorem, you need to find the square root. So you have to know this method to apply into deeper math questions that we will do in the future itself. So like using this part here, they've given us using the square roots of numbers to solve problems. So like the questions like this, like obvious questions that may come, find the length of a side of a square of area 441. So when you talk about a square, how do we find the, like, area? Area is equal to the side multiplied by side itself. So a times a, or you can put it as a to the power of 2. So just to show the power, I'm going to put this sign there. So a squared. So if I want to find the length, I have to find the square root of the area that they've given. So the square root of 441 can be found using the method that we just followed. So that's like pretty much it from this entire chapter that we've worked out. These two methods is what you need to remember. But if you I hope this was really clear to all of you. But if you still have any questions, please do email to the email address that I've given below. And thank you for joining in. Have a nice day then. Bye bye.